Hi children, today we will take up chapter number 9 from the 8th standard science syllabus. The school bell goes and you are absorbed in the classroom lesson. All of a sudden the sound of the bell, the waves that emerge, they come and strike the pinna of your ear. Pinna. This is called as the pinna. These are the waves. The signals are sent into the ear and they go to the brain. Those signals, when they are deciphered, you come to know it is school bell. This world is full of sounds. Sounds that are acceptable, sounds that are disturbing, sounds that are high, low. So, today in this class, let us deal with all kinds of sounds. We hear a sound because the sound waves come and strike our ear pinna, P-I-N-N-A. This is called as pinna. Or you even call it as the outer ear. Outer ear. It's a part of the outer ear. Okay, next. Introduction. What are the things we study in this lesson? Sound plays an important role in our lives. Think that you are deaf. The world is shut down for you. Eyes and ears play a vital role in our lives. They play a very important role in enabling us to know about our surroundings. It helps us to communicate with one another. We communicate, we talk to others. How is that communication made to reach the other person? The air which is there as the medium, it carries the sound waves from our mouth to the ear pinna of others. They decipher and understand. If you are on the moon, you will not be able to hear anything because there is no air in the moon. Absence of air makes it impossible for sound waves to get carried from one point to the other. So you don't hear on the moon at all. How is sound produced? How is it produced? How does it travel from one place to another? Travel. How does it travel? How do we hear sound? What is the technique involved? Mechanics involved? Why are some sounds louder than others? Some sounds are soft, some sounds are very loud. What is it that makes the sounds very loud? Yeah, next. Here we have a few musical instruments. Harmonium. When you start playing the harmonium, the bellows get filled with air, bellows. And as the air that gets stored inside comes out through the reeds, beautiful harmonical sounds get produced. The reeds will be here inside. As you press the buttons here, keys here, the sound gets produced. Tabla to tabla and darga, you play, there will be vibration. Vibrations bring sound. So vibrations are key. When something vibrates, sound gets produced. So vibrations produce or cause sound. Here in sitar, the strings are here. These strings, when they are vibrated, the sound gets produced. Flute, you have the holes here. Rhythmical, sound production is very rhythmical, and the air as it moves through the point here and it goes through the different holes here, the flute produces different kinds of musical sounds. So these are some of the musical instruments. Next, sound produced by humans. How do we produce sound? See, place your fingers here and you have something very hard here. At this point you have something hard. It keeps moving up and down as you talk. Or you swallow saliva, or you try to breathe, or you try to speak. You have something very hard here which just keeps moving up and down. You call it as voice box. That is the voice box. The voice box produces the sound. Whether it's a shrill sound or a low pitched sound, whatever it be, all kinds of sound get produced by the sound box. Voice box. Voice box. In humans, the sound is produced by the voice box. Voice box you can feel by placing your fingers here. It moves up and down. Or the larynx. The scientific word for voice box is the larynx. Put your fingers on the throat and find a hard bump. I said that hard substance, you call it a bump. Something like a road bump. You feel it there. That seems to move when you swallow. This part of the body is known as the voice box. It is at the upper end of the windpipe. The windpipe starts from there, it goes down and it goes into the two lungs, the left and the right lungs. So it is at the beginning of the voice box, beginning of the windpipe, the voice box is there. Through the voice box, as the air passes through, the sound gets systematically produced. It is at the upper end of the windpipe. Two vocal cords are stretched across the voice box. Here, two membranes are there. They are the vocal cords. They are the vocal cords. Through the vocal cords, the air has to pass, or larynx, in such a way that it leaves a narrow slit. See, it is like this. Always it's closed. As the air passes through it, the sound is to get produced. Between them, for the passage of air passes through that. As the air passes through that, the sound gets produced. Sometimes you take out some thin leaf, cut it into two, place one over the other and place it on your lips and you start blowing through and you get sound, beautiful sound produced. You can whistle, you can produce beautiful sound by holding two membranes or two layers of leaf in between your lips and blowing air through that. The sound gets produced. Or you can do it with paper too. Even with paper you can. It leaves a narrow slit between them for the passage of air. When the lungs force air through the slit, through here you have the two membranes, through them the air comes out. The vocal cords vibrate, producing sound. Muscles attached to the vocal cords can make the cords tight or loose. Muscles are there at either ends. The slit becomes narrow or wide as the muscles move in and out. Accordingly, sound gets produced. When the vocal cords are tight and thin, the type or quality of voice is different from that when they are loose and thick. When they are loose, they become thick. When they get tightened, they become very thin. And this is the larynx. This is the larynx. And the membranes are here. They are shown here. It is shown from another angle. We will move to the next concept. Sound needs a medium of propagation. I told you, on the moon we cannot hear any sound. You two are standing one opposite the other and you shout. Even then your friend will only see the movement of your lips, but he won't hear anything. What's the reason? There is no air on the moon. There is no medium to propagate your sound. There is no medium to carry your sound from one point to the other. Sound can propagate through solids, liquids and gases. See, you just lie down on the table, keep your ear pinna close to the table, and with your fingers you start beating the table at a distance. You start tapping the table. You start knocking. You hear different kinds of sounds. You really enjoy that because the sound here is not traveling through air, it is traveling through a solid. It is traveling through wood. Sometimes you play with your friends. If he is good at playing tabla, he can play it right on the desk and you can listen to it from the other end by keeping your ear pinna close to the desk. Solids. Liquids. Even when as sound passes through the liquids, the sound is different. Gases. Normally how we hear gases. In fact, it needs a medium to propagate. Needs a medium. Without a medium, sound cannot move from one point to the other. So sound needs a medium for propagation. What is propagation? Getting carried from one point to the other. Be it solid, liquid or gases, it cannot propagate through a vacuum. Sound can propagate through solids. Say, the best example is the stethoscope that the doctor uses. He puts the two ends of the stethoscope in your ears and he places the drum part on your chest and he hears. The doctor checks us using the stethoscope. Here, how does the sound propagate? It propagates through the stethoscope. What is stethoscope made of? It is made of metal. Through that metal, the sound moves. He can hear the sound from within our body because sound travels through solids. See, from drum is here. From here, the sound travels into the ears of the doctor and doctor hears. Next, sound can propagate through liquids. See, all the animals which are there in water, aquatic animals, they hear the sounds propagating through water. In fact, this is how aquatic animals communicate with each other. They all communicate. They will be able to send signals. Next, sound can propagate through gases or air. That's what we do. As I talk, the sound gets propagated to my friends or those who are listening to what I speak through air. This is the reason why we are able to hear a person standing near us speak. We will be able to hear others speaking. So that is propagation through air. We hear sound through our ears. Ears are meant for listening. Of the five senses what we have, ears are important sense organs. The shape of the outer part of the ear is like a funnel. See, look at this. It's like a funnel. Because it has to collect waves and send waves inside. This is the ear tube. Ear tube. Through that tube, it has to send the sound waves to the eardrum. You have the eardrum here. So, collection of sound from the outer atmosphere and sending it to the ear, it is done by our pinna, ear pinna. The funnel-like portion is called as pinna, P-I-N-N-A. Sound enters through the funnel and travels till the end of which there is a thin stretched membrane. Here you have a stretched membrane, which is called as eardrum. This is a very delicate organ, a delicate organ. That's why we say don't put any pointed object into the ear. Be very careful. Sometimes to remove the wax in the ear, you put a pointed object inside it, we go and hit the eardrum, and eardrum may rupture. Thereafterwards you will not be able to hear at all, that ear becomes useless. So you have to be very careful, very careful. The eardrum is like a stretched rubber sheet, because it has to vibrate, no? As sounds from the outer atmosphere go and hit it, the eardrum should vibrate. The eardrum is like a stretched rubber sheet. Sound vibrations make the eardrum vibrate. The eardrum vibrates. Even going and shouting into somebody's ear is also very bad. Sometimes children play it. You go, keep your fingers and shout loudly. The gush of air that enters the ear may rush in and break the ear drum. Don't play such games. Ear is a very delicate organ. If the eardrum breaks, ear becomes useless. You have to take great care of your ears. So you should not shout into somebody's ears. Sound vibrations make the eardrum vibrate. The eardrum then sends vibrations to the inner ear. See, this part is called as the outer ear. Once you reach the eardrum, the middle ear starts. From this eardrum to the inner ear. This part is the inner ear. This is the middle ear. What do you have in the middle ear? You have the eardrum. That is the separating part between the outer ear and the inner ear. From here you have three very small muscles. Very small muscles which are connected to one another, connecting the eardrum with the inner ear. They are called as malleus, incus and stapes. Malleus, incus and stapes. They are given here. Malleus, incus and stapes. That's the inner ear. Ear bones they are. So when the eardrum vibrates, the vibrations get carried to the inner ear by these three bones. They are very small bones. Malleus, incus and stapes are very small bones in the middle ear that carry vibrations to the inner ear. What do you have in the inner ear? You have a semicircular canal here. Semicircular canals. There are three in number. 1, 2 and 3. Three semicircular canals are there in the inner ear here. And here down below you have something like a snail. It looks like a snail, you see. It is called as cochlea. Cochlea. And you have some auditory fluid inside it. The vibrations that get passed on to the inner ear make the cilia here in the semicircular canals vibrate, and even the liquid inside this vibrate. So there will be vibration. A series of vibrations get created in the inner ear. And here you have auditory nerves. Auditory nerves. The auditory nerves get the signals. Those signals get passed on to the brain through the auditory nerve. The signals reach the brain, and in the brain, in the auditory part of the brain, they are deciphered. Brain makes out what the sounds are. So it will be able to understand what the signal is, what the auditory signal is. So this is how the ear functions. Then the signal, say the eardrum then sends vibrations to the inner ear. Then the signal goes to the brain and we hear. We hear. Okay. Amplitude, time period, and frequency of vibration. Sound is a form of energy that is produced by vibrating bodies. That's what we learned. An object to produce sound, it has to vibrate. That's what you feel here. When you keep talking, if you keep your fingers here, you find your vibrations. You find vibrations. Okay. So, it requires a medium for its propagation. Hence, sound cannot propagate in a vacuum, as there will be no material to transfer sound waves. In a vacuum, there is no medium for propagation. So, sound doesn't move further at all. The back and forth motion of an object, due to which sound is produced. What is vibration? It is back and forth movement of an object. If you hold a paper here like this, a sheet of paper, and start blowing into that paper, speaking, then the paper will vibrate. You know, it will start vibrating. What is vibration here? It is back and forth movement of that paper slip. You call it as amplitude, due to which sound is produced, is known as the sound of vibration. This sound of vibration will have an amplitude. It is also known as oscillatory motion. It goes back and forth, back and forth, back and forth. Each back and forth, one complete movement is called as one oscillation. It's called as one oscillation. The regular rhythmic back and forth movement is referred to as the oscillation. Oscillatory movement it is. Next. What is the period of sound? What is the period of sound? A period can be said to be the time taken to do something. Here, whatever time there is taken for the vibration is called as the period. If an event occurs repeatedly, then the event is said to be periodic. See, you have a clock. It keeps on beating seconds. You say the sound is periodic. There's a regularity, there's a system, there's a discipline. You call it as a periodic sound. When any musical instrument is played, the sound is very periodic. Because it's periodic, you enjoy that sound. You enjoy the sound. When it's noise, the sound won't be periodic. It's all mixed up. The time taken by the periodic event to repeat itself is known as the period. A second beats once in a second. The time taken by a second, that sound takes 1 second to repeat. From one sound to the other, whatever time gap is there, you call it as a second. The time taken by the particle to complete one vibration cycle is the time period of that particle. Here you see, this is how the sound is, the vibration is getting created. Goes down, you call this a trough. Goes up, you call it a crest. Again trough, again crest, again trough. That's how the vibration goes on getting created. Up, down, up, down. So, here, as the sound is getting produced, the vibrations get created. That's why we draw it like this. Goes like a graph. And from one crest to the other, whatever time it takes, from one crest to the adjacent crest, it is called as period. Now I am showing you trough here, from one trough to the other. It can be from one crest to the other. Time gap between one crest and the next crest, or one trough and the next trough. You call it as the period. The period. Next. What is the frequency of sound? The number of oscillations per second is known as the frequency of oscillations. How does it repeat? How does it go on? How frequent it is? You call it as frequency. How frequent is a sound? You call it as frequency of oscillation. Its unit is hertz. For everything there is a unit. For sound, hertz is the unit and is denoted by capital H, small z. Hertz. Hertz denotes the frequency of sound. The frequency of a wave is in general means how frequently the particles of a medium vibrate when a wave moves through the medium. See, you come see the frequency here. Crest, trough, crest, trough, crest, trough. Within a second, it may be 100 times, it may be 250 times, or it may be just 20 times. Now that is the frequency of sound. If it repeats often, then you call it a high frequency sound. Now this is a low frequency sound. Low frequency. In a second, number of vibrations created are less. Here vibrations created are more. Usually musical sounds will have high vibrations, high frequency musical sounds. That's why they are quite appealing. They stand out from other sounds. The frequency of a wave in general means how frequently the particles of a medium vibrate when a wave moves through the medium. So, through a metallic wire, if sound has to move, the sound goes on creating waves. Sound moves in a wavy pattern. Even as I speak, the sound reaches you in the form of waves. That means one wave, next wave, third wave, fourth wave. The waves keep moving out. Okay. What is amplitude of sound? Amplitude. The amplitude of a sound wave is the measure of the height of the wave. See, this is the normal line, normality. From here, how high the wave has gone or how low the wave has gone. See, this gives the amplitude. The amplitude of a sound wave can be defined as the loudness of the amount of maximum displacement of the vibrating particles of the medium from their mean position. This is the mean position, normal. From here, sound particles, how much do they get pushed away from the mean? That gives you the amplitude. How much of disturbance is there? How far do they get moved, pushed apart? That gives the amplitude. It is the distance between crest or trough and the mean. From the crest or from the trough to the mean, whatever distance is there, you call it as amplitude. And the mean position of the wave. Next. See, types of sound. Audible, inaudible. Some sounds are heard. It's not that we hear all sounds. Lots of sounds get produced and some sounds make an impact on our ears, some sounds do not make an impact. So types of sounds, audible. Audible sounds are those that we can hear. Audible sounds will always be between 20 and 20,000 hertz. 20 hertz to 20,000 hertz. It should be within that. If it's more than 20,000 hertz, we cannot hear. If it's less than 20 hertz, then also human ears cannot hear. Inaudible cannot be heard. What cannot be heard is inaudible. Below 20 hertz, above 20,000 hertz, I told you. If it is within that, we hear. The sound that earth produces as it spins on its axis, we don't hear. If we keep hearing, we will not be able to stay alive at all then. Such a huge sound it is, we cannot hear. Sometimes when there's a cyclonic ambush of air, we don't hear anything, or on a plain ground, some dog will be just giving a whistling sound looking at the skies. It's hearing some sound which you and I cannot hear. The dog is in a position to hear. Everything will be silent, the dog will be barking. Some sound which are inaudible to our ears is being heard by the dog. Different animals have different spans or levels of listening to audible sounds. Okay, next. Noise pollution. See, this world is full of noise pollution, we always say. Let's keep it peaceful. Let us not pollute. Let us not pollute by noise. Too much of noise is not good for health. Noise pollution is generally defined as regular exposure to elevated sound. High decibel sound. High decibel sound. If it is getting produced around your house all the time, 24 hours a day, you will not be able to live a happy life at all. There won't be peace. You keep getting disturbed. As regular exposure to elevated sound. What's the elevated? High. There's a hotel right in front of your house, Daba, and he puts huge sound boxes and he plays sound. He wants customers to come. And for you it's a disturbance. For half an hour you may just enjoy. But if it is played the whole day, you go and complain to the police or tell him, you please shut it down. I cannot stay here. That may lead to adverse effects in humans. You may go deaf over a period of time. You may not be able to hear well at all. Or other living organisms. Even other living organisms find it a nuisance. According to the World Health Organization, WHO, sound levels less than 70 dB, 70 decibels are not damaging. The maximum level should be 70 dB, it should not be more than that. To living organisms, regardless of how long or how consistent the exposure is. It may be over a short period of time or over a long period of time, but not good for human ears. You see different sounds. See, a helicopter is flying very close. It's very painful. Helicopter sound is quite painful. Then here some crane is making sound. Some other vehicle is here. See, speaker box, sound of the car. For a short span of time, fine. But if it continues, it is disturbing. Then mic, sound boxes. Yeah, even some of the shrill sounds, musical sounds, for a continuous period of time they turn to be a nuisance. Okay. Effects of noise pollution. What are the effects? What happens if you get subjected to noise pollution over a period of time continuously? See, you come under irritation. You get irritated. You may just try to keep your ears closed. You may have a piece of cloth bound around your ears. You can't sleep properly. Nervousness. You become nervous. You won't have peace of mind. Human brain needs peace of mind. It gets disturbed. Sleep disturbance. You won't have right sleep. You get awakened now and then. Increased blood pressure. Your BP will go up. Too much of disturbance in the atmosphere. All these lead to increased stress. Your stress level will be high. So, noise pollution has impact on human brain. Too much of noise in your surroundings is bad for health. Keep in mind. Now, how to control? Control measures. How to control? See, some of these are very simple. We can practice. Plant bushes and trees in and around sound generating sources is an effective solution for noise pollution. If there's too much of sound, plant trees around. Plants absorb sound. Having trees around, bushes around, these will help in reducing the sound level. So plant more and more greenery around the disturbing point. Say in factory, it is creating a lot of sound. Plant lots of trees in and around the factory. The sound level will go down. Regular servicing and tuning of automobiles can effectively reduce the noise pollution. You have to service your bike or scooter or car regularly. Machines have to be serviced regularly so that the sound level will be low. Proper servicing of the vehicles is essential. Then, buildings can be designed with suitable noise absorbing material for the walls, windows and ceilings. You know, theatres are designed by special craftsmen to see that the sound pollution level is as low as possible. They will have different absorbing materials on the walls to bring down the echoes. If too much of echoing is there in a theatre, you will not be able to enjoy the movie at all. The sound system should be good. Sound absorption too has to be good. There should not be echoing of the sound. Then workers should be provided with equipments such as earplugs. If there is too much of sound in your office or your workplace or in a place where you study, you can have earplugs or earmuffs. Usually when you move in a plane, they give you earmuffs to see that there's less of a stress level on your ears as the plane takes off or it lands. The sound will be very high at that time. Now these are the different measures you can take to see that the sound is kept under control and you do not get disturbed much. Thank you, children.